Now let's do one more example. Note that now it is an initial value problem, but the procedure is still the same. So in order to move y squared to the left-hand side, we've got to multiply our differential equation by y squared, and in order to move dx to the right-hand side, right, so we need to multiply by dx. So then we are going to get, on the left-hand side, we are going to get y squared dy, and on the right-hand side, we are going to get 4x cubed plus 1 times dx. And then we write the integration sign. Now we've got to find the antiderivative. So here we get y cubed over 3 equals the antiderivative of 4x cubed is x to the 4 plus x plus constant. Well, now what the initial condition can tell us is that now we can solve for c, because the initial condition tells us that x equals 2 and y equals 3. So we can just substitute it and solve for this constant. Well, maybe let me rewrite it a little bit like this. I'm sorry. Y cubed equals 3 times x to the 4 plus x plus c. Then x is 2, so y is 3. 27 is 3 cubed equals 3 times x to the 4. 2 to the 4 is 16 plus 2 plus constant. Right? So then 27 divided by 3 is 9 equals 16 plus 2 is 18 plus constant. So our constant is -9. Yeah? So therefore our y cubed is 3 times x to the 4 plus x minus 9, and y itself is going to be 3 times x to the 4 plus x minus 9, everything to the power 1/3. That's the answer. Now, well, we found the answer, so it is a good idea to verify it. Strictly speaking, it is not necessary, but for the purpose of this lecture, and well, if you are on a midterm test, it is really, if you have time, it is really an excellent idea to verify your answer. So the answer is that we just found is y equals 3 times x to the 4 plus x minus 9 to the power 1/3. Let us verify the initial condition first. So in the initial condition, y should be 3. And then is it true that 3 equals 3 times 2 to the 4 is 16 plus 2 minus 9, everything to the power 1/3. Correct or not? So 16 plus 2 is 18, minus 9 is 9, 3 times 9 is 27, and cube root of 27 is 3, so it is correct. Okay, fine. The initial condition has been verified. Now let us verify the differential equation. So the left-hand side of our differential equation is dy dx. So let us find dy dx. So here we have the power 1/3. In order to differentiate the power of 1/3, we write 1/3 times 3 times x, well, whatever expression we have, x minus 9. And then to the power 1/3 minus 1. 1/3 minus 1 is minus 2/3. Minus 2/3. Times the derivative of whatever is inside 1/3, the power of 1/3. So, and that is, there we have 3 times the derivative of x to the 4 plus x minus 9. Then the derivative of x to the 4 is 4x cubed plus 1 minus 1, 0. Okay, excellent. And notice that 3 and 3 cancels out. Now, the right-hand side. The right-hand side is really 4x cubed plus 1 times y to the power minus 2. So 4x cubed plus 1 times, where is our y? So our y is 3 to the x to the 4 plus x minus 9 to the power 1/3, and then to the power minus 2. But then when we raise a power to another power, is the same as to multiply the exponent by minus 2. So I should just write minus 2 here. And now you see that I got exactly the same thing as the left hand side, which means